So, welcome to our first experiment on Power System Lab. So, this is our first class also in Power System Lab, and since I think you all know that we are going to conduct classes in this virtual platform, even for Power System Lab also this year. And let us first go through the syllabus of our Power System Lab. Okay. So, for that, let us see. Okay. Let us first see the syllabus of our power system lab. Yeah. So we will be using many virtual platforms to conduct your class in full. And the power system lab syllabus here. Syllabus consists of two parts. As you can see here, I have partitioned it as module one and module two. So the first part will consist of simulations, and in your syllabus, you have these experiments: Vibus formulation, load flow analysis, in Gauss-Seidel method, Newton-Raphson method, fast decouple method. Then about short circuit analysis means symmetrical fault and unsymmetrical fault, stability analysis. Okay, and this about power system stability things and reactive power control as well as solar power calculation. So these many experiments are there in under simulation experiments in your power system lab syllabus. Okay, and there are hardware experiments also. Hardware experiments mainly consist of this testing kind of experiments like high voltage testing, power frequency, impulse testing, high voltage DC I mean these are all breakdown tests basically. Then we have relay testing of our current relay and our voltage relay. Then we have insulation testing of LT and ST cable, earth resistance measurement, testing of CT and PT, testing of transformer oil. Again, this testing of transformer oil means that you will be dealing with the breakdown test of the transformer oil. Then you have testing of dielectric strength of solid insulating materials. So that is another thing. And testing of dielectric strength of a power factor improvement, then string efficiency of insulators. So most of them are high voltage experiments or related to power system production experiments. And as per your syllabus, out of the simulation and hardware experiment, in simulation experiment we have to do at least let me say a total of 12 experiments need to be conducted, out of which at least 4 experiments should be from this hardware kind of experiment, and remaining 8 like we can, it is as per our time, and uh, at least we should be doing 12 experiments. So that is what we are going to aim at. This is your syllabus. Okay. Now, what are we going to attempt today? Okay. So, we are going to not as per the order and all. So, first thing we are going to attempt is this testing of transformer oil. Okay. So, first, what we are going to attempt is testing of transformer oil. So, means we will be doing this only. This here, in this thing, this 2.1.9. This is what we are going to do. Okay, testing of transformer oil. So that we will conduct, and uh, in this particular lecture. So for conducting this transformer testing or testing of transformer oil, let us see some theory associated with it. Yeah. So if we see the theory associated with it, let us see. This means you have these all experiments. Most means these all experiments you have already studied in what I can say in your power system analysis class, or may if, any of some people might have taken high voltage as their uh, elective in the last summer in S6, right, in S5 or S5. So there you might have already studied. So we are going with that again. So uh, so our first experiment is testing of transformer oil, and aim of the experiment is to measure the dielectric strength of the given sample of transformer oil. We all know where transformer oil is used, right? You are aware of. That's right. So we all know where your transformer oil is used. Where it is used, it is used in, you can say, inside transformer it is used. That is why we, often call it as transformer oil. Basically, it is refined mineral oil. Right. So, and other than that, even it is used in other like circuit breakers and all in several applications. Others. Basically, what is the good part of transformer? Inside a transformer, the transformer oil is having two functions. One is that it is having good insulating properties, right? Whether it is winding to winding insulation or from winding to the outside structure, you have transformer oil is working as a good insulator. At the same time, it is able to take out the heat from the core of the core or transformer windings to the outside. So these two functions it is doing. So we in high voltage engineering or when it comes to such materials, we often select something based on several properties. Understood. So we often select something based on several properties. And one major property is what? How much volt? How much? What is the breakdown strength, or what is the dielectric strength of the given sample of transformer oil? How do we find out? Usually, we say that in terms of voltage per meter, right? Voltage per meter. This or a kilovolt per mm. So this is the way we usually depict the breakdown strength of transformer oil, and it will depend on several factors. Right. Now, let us see how your experiment is conducted. Okay. Usually, what we do is that we will have a high voltage lab, and there you have to conduct this experiment. Like you have a high voltage supply, and you apply this high voltage supply to your transformer oil, and it will take its time to get at a particular voltage, it will get breakdown. Okay. And there is some statistical analysis also. So we will get into that quickly. But how our experiment is conducted here is that now, since you are all at home, we will be conducting it through a virtual platform. It is from MHRDs. There is a concept of virtual labs. Maybe you might be already aware of. So, using a virtual power system lab created for this purpose, there we are going to perform this experiment, and you have to write your records and all. Okay, and apart from this virtual platform, we are also using MATLAB. MATLAB. Apart from this, for making some like Weeble plot for understanding the dielectric properties that we will discuss. Okay. So this is what we are going to do. Okay, I have already given you an assignment for learning MATLAB through completing their MATLAB on-ramp course. So I think you might have already taken, or if you are in between, this will be just a practice, and you can follow along with me. Right. So, but and one more thing I want to say is that what all things are expected in your lab record. Okay, you have to write your lab record. You should have an aim, theory, connection diagram, procedure, observation table. These all things should be there. As that is always there. Okay, and these are available. This aim, theory, connection diagram, procedure, and observation table. These are all are available in your lab. Uh, this virtual lab platform also, so you can see and write it down from there. Okay, if you want to write on your own procedure, that is good, more good. Then in the result plot, apart from that, you have to plot a variable plot. Okay, we will I will tell you why it is needed afterwards, and you have to write results also. Result means just do not copy something from somewhere. Okay, so in result, you write your understanding, what you understood from your this experiment. Then here there are the three parameters, which are the scale parameter, shape parameter, and the average breakdown. Okay, so these things also we will discuss. So now let us move on to doing this experiment. Okay, so now let us move on to doing this experiment. So what are we going to do? Hmm. Okay. As I have already said, we will be using this virtual power lab. Okay, so and I will share this link to you. And here under experiments, there are many experiments. And under this particular experiment, as you can see here, uh, there are several experiments. Here is the our experiment, which one is which is what to measure the dielectric strength of transformer oil. You can click that, then you will come to this menu. So here is where you find your objective and all. Like this is your aim. Okay, aim of the experiment is to measure the dielectric strength of transformer oil, and one figure is moving through here. So this is what it will look like in reality. Okay, when you are when you are in a high voltage lab, this will be this is what it will look like. We can get into more details. Like these are some of the equipments. Okay, this is the test cell. Okay, so you may not be able to. So, so as you can see here, this made of perspex usually. So this is our test cell in which we add transformer oil, and you have an electrode arrangement like this. Okay, electrode arrangement shape is in such a way that your electric field strength is quite uniform all around. So it will not be like what I can say, not like something like this. More than that, we will have a curved surface. Okay, and that is as per specific standards and all. So that is that. And this is such a thing. And similarly, here also you have another one, right? This is another kind of electrode arrangement, and this also is there. Okay. So the upper this one and this one, these two things. The peculiarity is that your supply source also means whatever you are seeing beside this. This is your supply source. Okay, means below this, the supply source is directly connected with the structure, or we get the whole experimental setup as such. Then another thing what we have is that here, as you can see, this is our transformer. Uh, Another thing what we do is that we have a transformer. This is the high voltage transformer. Okay, on from the top view you can say that it is like a column of that thing down. Then we use this cell along with this high voltage transformer. So these are the two ways in which we apply, we conduct transformer oil breakdown test. Okay, so let us get into the experiment. Okay, this is the connection. This is the connection diagram. As you can see here, as you can see here quite clearly, in this. Uh, Let me say this is the part which is concerns with the testing part. This is your transformer, and on your transformer terminal, you are applying your this transformer oil cell, you know, say with electrode arrangement, where you are conducting your experiment, and you have a cable connected to the control room. Means this big part, this will be outside the place where we are conducting experiment. In a high voltage lab, we normally don't go and means our measurement and control equipments will be away from our high voltage transformer. That is for safety purpose. That is this is the control part of the experiment, and here this part is what this is your or this high voltage testing component. Okay, you have a voltage voltmeter here, high voltage voltmeter. The voltage measurement is available, and using that we will be making the measurements. So everything is here. That is what I want to say. Like you have to go through this. Like this, the theory and procedure of the experiment is there. Okay, you can see this for yourself. So what we usually do is this much only. We apply high voltage and see at what is the voltage at which your the transformer is going to break down. So that is what we usually see. Okay, and your observation table should look like this, like one serial number and breakdown voltage. So we will take several number of readings. Why? Because when it comes to breakdown, or when it comes to a transformer oil kind of thing, then this breakdown voltage will not occur at the same point at every time. Mainly when we are using the same oil again and again. Once we use the oil, in that if we again conduct breakdown, then it is already its property has changed to some extent. So there is some carbonization, right? So because of that, again it might break down at a lower voltage afterwards. Even from with respect to temperature, with respect to other factors, it is quite. It is not like what I can say, like measuring a resistance or something. Breakdown strength, even though measured for the same kind of transformer oil from the same can, if we take again and again and test, still we are not going to get the same voltage breakdown voltage every time. So it will have a variance, right? When it varies, and when it varies over a sufficient gap, then usually it is represented in a statistical distribution, and it is seen that it follows the Weibull distribution. And there are two parameters of Weibull distribution, which are the scale parameter and shape parameter. Scale parameter represents the breakdown voltage or breakdown strength, right? Dielectric strength or the breakdown strength. It is represented by scale parameter, and shape parameter will represent what is the variance of that in the samples we conducted. Understood? So when your shape parameter is very high, then we might not be that confident to say that, yeah, we are getting our breakdown strength obtained is quite correct. When your shape parameter is lesser, then we can say, yeah, our breakdown strength might be nearby our scale parameter. So, and there are some other standards, like they see whether there is some large variation or not. So since there is not like large variation, then we take average of the breakdown strength that we obtain for at least like 4 5 sets of transformer oil. This 4 5 sets of transformer oil also we conduct our experiments for at least at least 3 times. Okay, so that we will see now. So that is what we are going to do. We are going to conduct this test breakdown test of transformer oil up to this is 3, right? So 3 for the same oil. Like that, we will conduct at least for 5 sets of transformer oil. So we will have 15 readings. Understood? Then you all will have different readings. That is how the simulation is there. So now let us see the simulation part. Okay. So if you come here in the simulation part, you can see, you can click on this checking the dielectric strength of transformer oil. Then he will come into this particular window. Let us see. My God. Wait for a second, it will come. Okay. Okay. Let me handle that one. Okay. So when you click that, you will come to this particular simulation window. Okay. So here you can see different things. This image here shows your transformer oil where you can see two wires are connecting into the high voltage transformer. And on the other part here, you can see voltmeter that which will show the voltage reading. And here using this green button, we can increase our voltage to the breakdown voltage. And here the graph between voltage and time will show the way your voltage is getting applied. Okay. And at a particular time when your breakdown happens, What will happen when breakdown? Breakdown means what? Breakdown means your transformer oil is becoming conducting. So there will be a high current flowing there at that particular stage. So your relay trips, and that time whatever be the voltage applied, that is stored in the voltmeter. That is what we measure as the breakdown strength. Okay. So let us first start the test. Like what we should do, we should increase voltage. So now I have increased to 1 voltage. Now 2 voltage, 3 kV, 4 kV, 5 kV, 6 kV, 7 kV. You can see that voltage is increasing on this side. 10 kV, 11 kV, 12 kV, 13 kV, 14 kV, 15, 16, 17, 18, 19. Like that we are increasing. 29, 30, 29 points. So after 29, we are increasing slowly. Okay. So when in an automatic arrangement, this is what we usually happen. So 30.9, 31.1. So at the voltage 31.4 kV, our what this breakdown voltage happens. So in your observation column, you have to note down this voltage, which is what 30 experiment number observation number 1 is. The breakdown happened at the 31.4, and I believe you have seen this breakdown here also, or you did not see. You can see this part of the figure for next time. Okay, so I will increase it a bit. Okay, so now let us again see. Like 31.4 kV, it is already applied. Now we have to restart the test. Again, we are doing it on the same sample. So again, 1, 2, 3, 4, 5. Please see the image part here. Okay, the transformer oil part here. So you will get an idea about what will happen in reality. The image part in transformer oil. I am just increasing the voltage. You can see how the increment goes. See, you can see a flashover, right? So the in reality, this is what happens, and you will get your next breakdown voltage, which is what 30.1 kV. So you have to note down that. Now we will again conduct the test. So increase voltage. I'm increasing it. You can see that it is going a different path. That will depend on its current and all. So you got another voltage. This is another thing, which is what 28.5 kV. Right. We got another voltage value 28.5 kV. So once it has happened, you can see in red line here, it is recommended to change the fluid after 3 breakdowns. So in reality also that is what you do. After 3 breakdowns and all, there will be carbonization over the electrode, and the transformer oil will be spoiled a lot. So that time what we will see, we will change the transformer oil and again start the test. So these 3 readings you have already taken. Now this is the fourth reading. Okay. Now again we will conduct the test. So in the fourth reading, you will get another value, which is 31.2. Understood. So like this, we will continue our testing up to what? Up for at least 5 sets of transformer oil that you have to do. And just note down the breakdown voltage every time. So you will have 15 number of readings. Right. You will have 15 number of readings. Once you have this, one way is what? One way of finding the breakdown strength is taking average. Another way is that, as I said, it is the variable distribution. So we have to fit it with the variable distribution and find out what is the shape and scale parameter. Okay. For that, what I am going to use is that what I will be using. I am going to use the MATLAB. Okay. So if you can type MATLAB online, online in your Google Chrome, or even if it is your MATLAB app, there also it is there. So MATLAB online is there. So if you did not log in, or if you don't have an account, you have to make MATLAB account. I have already logged in and I have a MATLAB account. You have it and you have to create it with your college email ID. So let us start using MATLAB online as well. Okay. So you are getting your MATLAB online will get started. Okay. So this is the how your window will look like. Right. This is how your window will look like. So with this, what we are going to do is that it means even in MATLAB online also we can do this. If you have MATLAB in your system, it is good. Otherwise, also we can do. That is what I want to say. Okay. So let us continue with this MATLAB online. Okay. So we are going to use MATLAB online for this purpose. And I think you understood how to come into this thing. So first, before doing anything else, let us say we will start using this live script. So start this new live script here. You can click that, and once you click that, you will have a window like this. And as you can see here, this is now like untitled.mlx, right? So we have to save this thing, right? So what we can do, go to home, okay, then okay, there is a save option, live editor. Okay, yeah. In live editor tab, you can find save here. So put save here. Okay. So it is now untitled. Since it is for breakdown strength, let me type it as transformers oil. Okay. Transformer. Let me say its name is transformer. Okay. It is for transformer oil. So, and I clicked OK. Now, our live strip name is what transformer.ml. Right. So when you are doing MATLAB programming, I wanted to tell the correct way of doing it. Okay. So in order to when we want to write something which is not really the command, which is not really some command, but only a command, right? In C programming, and you might have seen here we have to use percentage before when we are doing that. So what is the program for? It is for finding the breakdown. Let us say it is for what transformer oil testing. Okay, this is how usually we write a program. Now we will get into the real parts. Okay, so let us start or let us get into this program. Okay, during your experimental simulation part, you have already noted down the 15 values, right? 15 readings corresponding to this breakdown voltages, right? So that is what I am going to do. So yeah, let me increase it a bit more. Okay, I think now you are able to see properly. So it is a became okay. So in transformer oil testing here, first what we have to, it is quite similar to like metrics. Okay, so my input is what breakdown and not just breakdown. Sorry, breakdown voltage. So that variable I am marking it as BD underscore V. Okay, you can take any variable name. So break BD underscore V. And inside that, I am going to write or what I can say that 15 times. Whatever I got for 15 times that I am going to write. Okay. So that you will get some value. Now, just for making you understand, I am writing some values. You have to add whatever values you got from the simulation experiment. Okay, that values. These are in kilovolt, 31.5. Okay, 29.8, 30, 29, 28.6. This is just for value sake. Okay, 31.2. Okay, how many are now? 2, 3, 1, 2, 3, 4, 5, 6. 32, 7. Right. So some values. Okay, you can add up to 15. Whatever number use fields use. So this way I added the breakdown voltages. Right. I have already added the breakdown voltages, and even you can uh, change the way it looks also. Like you can put output on in line, so it will come down. So now my this is our out my voltage breakdown voltage values I got. So my results are what? Results are, one is what, average breakdown voltage. Right. So for average breakdown voltage, what you should see. So let me say. since it is average breakdown voltage, I put a before that. So, and this is my average breakdown voltage, right? So average breakdown voltage means what? The average of all these values. That we can also write as it's a code, okay? Mean of what? Mean of our breakdown voltages, okay? Mean of our breakdown voltage. So that will give us the average breakdown voltage. That is one result. Now the second part is what? Second part, as I said, we have to see the variable distribution, right? This is the variable distribution. So we have to see variable distribution, and for that, let us first plot the variable plot first, right? We will see what is the variable plot. So, or let us do one thing. Till here, this average breakdown voltage is there. Na? Till that, we will run it first and see. Okay. So till this average breakdown voltage, you can see run section or run. Okay, complete run. So this here will give us what? That will give us the average breakdown voltage. So from here I gave a some values ranging in that, and I got my average breakdown voltage as 31.230. So that means 31.23 kilovolt is the average breakdown voltage. Now, as I said, it might vary. So in order to understand the variation, we have to see the variable distribution also. So what I will do, we have to see the variable distribution also. So for that, what I am going to do, first I will plot the variable distribution for this curve. So for that, the code is WBL plot. Yeah, WBL plot. So okay, you plot of what? Of this breakdown voltage. So I am giving that breakdown voltage thing. So that will give me what? That will give me the variable plot of this thing. And I also want to like let us see here that this is the uh, breakdown parameters. Parameters means what? This variable parameters, which are the shape and the scale parameters. So W B D, we can put whatever value you like. Okay, breakdown parameters. That how we will find out. That is through WBL fit. Okay, variable fit of what? Of our this breakdown voltage array. Okay, it's an array. So this is what this is what is going to give me the variable plot as well as the PD or WP. Okay, so if I run this thing again, what I got, this is my variable probability plot. Okay, I think you are able to see here, right? So let us, you can open it in figure window also. So this is my variable probability plot. You can see this line here. If your data points are all mostly in is nearby this line, then you can say it is somewhat fitting. So this is the way you have to put this variable plot in your record. So since now you are uploading, you can directly add this in Google Classroom. Okay, so for that you can use this save figure option here. Understood. So you can put save figure. Okay, you can take it out. Okay, understood. So this untitled figure, let me say, let us mark it as variable, and you can save it in what? JPEG will be enough. Okay, JPEG form if you save it. Understood. Okay, in the MATLAB drive, and put it as save. Understood. So that way, that way you can take it out for submission. Okay, you can save this, and that variable figure is now here. Okay, sorry, save as. Okay, so this way you can take find a what I can say, you can save it some way, okay, and send it to me. So that is the thing you have to do. So with this, we made the variable plot, and another thing to see here is what, that is the fit values. Okay, you get two values here. The first parameter is what, 31.86 for it. That corresponds to the scale parameter or your breakdown voltage, and the other parameter is the shape parameter, which shows the variance. Okay, so this is what you have to do. This we got our scale parameter of the value corresponding to breakdown voltage as 31.86 here, and see what is the average value. The average value is 31.23, it is 31.86. So they are quite nearby. Right. So this is the way to conduct the experiment. I hope you understood this, and you have to submit this whole thing, including this program, and you can write your own program, your own variable and all this thing you can submit. Understood? And that is about this. Mm, once you have written all these things, then you can download this, or even one second. You can download this variable.jpg here. Understood? So if you save it down, so you will get this thing, variable.jpg, and if you take it out, you can see that. Okay, this is your variable probability plots. You can directly download it. Once you save it, then you can download the same also. Okay, and other codes and all you can copy and paste as you wish. So see what you can do, and complete this experiment by 23rd. Okay, by 23rd, and submit it in Google Classroom, which the link will be provided. Okay, that should include what, your whole written uh, experiment for the transformer oil testing, as well as this variable plot and with the result and all. Okay, so this is how we will be continuing our lecture. So that's it for today. So next lab we will see another experiment in the similar way. Thank you.